Let's take a look at applying exponent rules, scientific notation. Now we got our standard form, and then we also got our scientific notation. Boy, I'm not spelling very well right now. Scientific notation. Don't usually have trouble with that in class. Okay, what we're going to have is we have a single digit, and this will be from 1 to 9. Then dot, and we'll have some more digits here. And we're going to drop off the trailing zeros. So any zeros at the very end you drop off. Now that first digit can't be 0, by the way. It has to be between 1 and 9. And then this will be times 10 to a power. And that's our scientific notation. Now let's take a look at our first problem here. This is 315 million. There we go. And if I were to put a decimal place, it'd be right here. And the instructions say write each number in scientific notation. Now what we want is we want to move our decimal place until we just have a single digit and then a decimal, the decimal point. So I'll move it 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So this is going to be 3.15. And all these are trailing zeros, so I drop those off. And times 10 to the 8th power. Now, I'm going to summarize each of the rules as we go along. So here we're going from standard to scientific. And if you move your decimal point to the left, so if you move your decimal point to the left, you're going to have 10 to a positive power. Now there's no doubt how many decimal places you move it to, but it's whether it's going to be positive 8 or negative 8. Let's look at another example. This is going the other way. So we got 0.123 23517. Okay, now we want our first digit to be between 1 and 9. So I'm going to move my decimal point to the right until I get that. So move 1, 2, 3, 4 places. So we're going to end up with 5.17. Now you drop off the leading zeros also. And it'll be times 10 to some power. Now we moved it 1, 2, 3, 4. Wait a minute. 1, 2, 3, 4 places. So it's either going to be positive 4 or negative 4. Well, in this case, it's going to be negative 4. And let me summarize that. So if we're going from standard to scientific, and you're moving your decimal point to the right, then you're going to have 10 to a negative power. Used to be a chemistry instructor here that she taught it that this is the big number up here. So we'd want to put a positive 8 here because 10 to the 8th is a big number. This is a small number, so we'd want to put a negative 4 here because 10 to the negative 4 is a very small number. I thought that was kind of a neat way to think of it. It doesn't work if you got kind of a number that's in between a large number and a small number, but it handles most circumstances instead of memorizing the rules. Let's look at this one. Got 310. If I were to put a decimal point, it'd be right there. So I'm going to move it 2 places to the left. Right there. So we'd have 3.1, I'll drop off the trailing zeros, times 10 to some power. Well, moving it to the left, that's what we did right here. Moving decimal point to the left, it's going to be a positive power. So we moved it 2 places, so this will be positive 2. And these are our answers. This is one that might be kind of iffy. Move it to the left. Well, 310 is kind of a large number. And, you know, that's what I'm saying. Is it or is it not? So 10 squared is a large number. If we're talking about dollars, and yeah, that's a pretty good chunk. Let's go in the other. Let's look at some going the other way. We got 7.18 times 10 to the positive 3 power. Now, they say write each number in decimal notation. That's the same as our standard form. Some books call it standard, some call it decimal. And here, we're going to, here's 7.18, and we got third power. We want to move our decimal 3 places to the right. So 1, 2, 3, and this is where our decimal point will be. And since I didn't have a digit here, I had to put a 0 in there. So our answer is 7,180. Let me summarize this. We're going from scientific to standard. And if you got 10 to a positive power, then you move your decimal point to the right. So if you got 10 to a positive power, you move your decimal point to the right. Let's take a look at another one here. We've got 3.2 times 10 to the negative 4. So here's 3.2, and we want to move it. It's negative 4, so we'll move it to the left. So move it 1, 2, 3, 4. And this is where my decimal will be. And I had to put zeros in here for these missing digits. So our answer is going to be 0.03032. Typically you put a 0 before the decimal just so you don't lose track of it. Now here we're going from scientific to our standard form or decimal form, and we got 10 to a negative power. And we're moving our decimal point to the left. Okay. Using kind of a shortcut way of doing it, 10 to the third, that's a big number. That's like 1,000. Well, this should be a big number. If I moved it to the left, I'd have a very small number. Now 10 to the negative 4, that's a small number. So this should be a small number. So that kind of tells you if you went the right way. And do I have those pages saved? Let me see. Pretty sure I do, but let me check. Yes, I do. Okay. So let me just start a new page. And let's look at our next problem. We got 7.8 times 10 to the 7th power. And we're writing our decimal notation, our standard form. Well, 10 to the 7th, that's a big number. So when I get done, I want a big number, which tells me, without even looking at like that chart, that I want to move it to the right. So move it 7 places to the right. So 1, 2, 3, 4, 5, 6, 7. This is where decimal will be. And for these missing digits, I want to put 0 placeholders. So I'll have 7, 8, 6 zeros. 1, 2, 3, 4, 5, 6. So that gives us 78 million. Sometimes that's these are beneficial in calculations. 2 times 10 to the negative 2, and then 9 times 10 to the negative 3. Well, what that means at times, it means 2 times 10 to the negative 2. Nothing fancy. And I'll put parentheses around to indicate multiplication. And this one means 9 times 10 to the negative 3. Well, multiplication is commutative, so I can flip these around. Put the 2 times 9 together. And then 10 to the negative 2 next to the 10 to the negative 3. 2 times 9 is 18. And 10 to the negative 2 times 10 to the negative 3. When you multiply 10 to a number times 10 to a number, think of like when you had x's. X squared times x to the 4th. You added the exponents. Well, same thing here. We'll add these. Negative 2 and negative 3 gives us negative 5. Now this isn't in scientific form. Express your answer in scientific. So we need to get it there. Well, let's first put it back to normal form. Here's 18, and here's our decimal. 10 to the negative 5, that's a small number. If I moved it to the right, I'd have some huge number. So I want to move it to the left. So I'll move it 1, 2, 3, 4, 5. And that's where our decimal will be. And I'll put zeros for these missing digits. So we got 0.12318. Okay, let's put it back into scientific notation now. I want the first digit on coming from the left that's not 0, which is 1. So we'll have 1.8 times 10 to some power. Well, here's my decimal point. Move it 1, 2, 3, 4 places. There's no doubt on what should be here. It's to the negative 4. And that's our answer. Again, this is a very small number, so this has to be a small number. Not too bad of a way of thinking of it, really. Let's take a look at this problem. We've got 30 million divided by 0.123 zeros. Yeah, 5 zeros. 1, 2, 3, 4, 5, 5 times 20,000. It says perform the indicated operations, express your answer in scientific notation. Well, let's put them into scientific notation to begin with. So the top part is going to be 3.0 times 10 to some power. If I think where my decimal point is, it's right here. So I'll move it 3, 6, 7 places to the left. So that'd be 10 to the 7th. Again, this is a large number, so this should be a large number. Now here, this will be 5.0 times 10 to something. Well, this is a very small number, isn't it? So this should be a small number. So I know it's going to be a negative. Here's my decimal point. So I move it 1, 2, 3, 4, 5, 6 places. So it'll be a negative 6 power. And this one will be 2.0 times 10 to something. Well, if I were to put a decimal point, it'd be right here. 20,000 is a big number, so this 10 to the power should be a big number, so it's going to be positive. So move it 1, 2, 3, 4. Okay. Well, let's split these up a little bit. Here we got 3 over 5 times 2. And then up here I got 10 to the 7th. Here I got 10 to the negative 6. And here I got 10 to the 4th. Now we covered these before. We don't want any negative exponents. So that 10 to the negative 6 I'm going to take up on top. So that's going to go up on top. Now this gives us 3 and 5 times 2 is 10. Now I take the I got 10 to the 7th here, take 10 to the negative 6 upstairs, becomes 10 to the positive 6. Remember, when you move anything opposite where it's at in a fraction, the sign of the exponent changes. And 5 times 2 is 10. That's like 10 to the first. And here we got 10 to the fourth. Well, you got 10 to the power times 10 to the power. You're going to add the exponents. 7 plus 6 gives us 13. And down here, you got 10 to the first times 10 to the fourth. You add the exponents. So that gives us 10 to the fifth. Well, 10 to a power over 10 to a power. Remember, you subtract your smaller exponent from the larger one. 13 minus 5 gives us 8. And we have 10 to that power where the larger one was, which was up on top. When I say larger, I'm talking about in terms of the exponent. So larger exponent. And then you have 1 down here, which would just give us 3 times 10 to the 8th. You don't have to put the 0.0 on there. That's scientific form right there. All right, so that's scientific notation. So we stop the recorder.